Hello, and welcome again to Math Counting. Alright, so last time we started with the introduction to differentiation, and today we are going to talk about the power rule and the chain rule. Okay, great. So, last time we spoke about differentiation. We said that differentiation was just finding the gradient of a curve. Okay, so talking about the power rule, last time we said that if you are given a function f of x, then f prime of x will be lim as h approaches 0, f of x plus h plus f of x all over what? H. Sorry, this is minus. H, right? Fine. So, what if we are given a function, say f of x? F of x is equal to some x, right? If it's equal to x, then it means everywhere we see x, we put x plus h there. So, we have f prime of x to be equal to lim as h approaching 0, x plus h minus f of x all over h. And this gives us lim as h approaches 0, x plus h minus x all over h. This cancels out, and then we have h over h, which is equal to 1. All right, so that means if f of x is equal to x, then f prime of x is equal to 1. Okay, so what if we say f of x is equal to x squared? Then f prime of x squared should be equal to x plus h all squared minus x squared all over what? H. So we have lim as h approaches 0. Never forget that statement, lim as h approaches 0. So we expand the numerator and get s squared plus 2xh plus h squared minus x squared all over what? All over h. So this goes away. And then we have lim as h approaches 0 of what? H into bracket 2x plus h all over h. And then we have this cancelling this. So because h is approaching 0, we have f prime of x squared to be equal to what? 2x. Okay? Now, so what if f of x is a constant? If f of x is a constant, it means it doesn't change, right? So since it doesn't change, there can be no x plus some higher term h or some term h, right? If we add h to it, it means x is increasing. And since it's a constant, it doesn't increase, okay? So if f of x is equal to some constant c, then f prime of x will be equal to lim as h approaches 0 of some c minus some c over h. Okay, clearly this is equal to 0. So anytime we differentiate a constant, we get 0. Okay, fine. Now if you look closely, you can see that there's a pattern now. Okay, so if f of x equals c, f prime of x equals 0. F of x equals x, f prime of x equals 1. F of x equals x squared, then f prime of x is equal to 2x. Then f of x is equal to, s cubed, f prime of x will be equal to 3x squared. So we can see that if f of x is equal to some x raised to the power n, then f prime of x will be equal to n x raised to the power what? N minus 1. Okay, so we just have to multiply x with the power and then take 1 from the power. Okay, so basically that's the power rule for us. Okay, so what if we have a rational function? Okay, we have a rational function like, say, f of x is equal to some 1 over x minus 1 over 3 square root of x squared. Okay, what we can do is we can differentiate each term separately and then bring them together. Okay, but we can do them spontaneously at a go-to. So here you can say that f of x is equal to x raised to the power minus 1 according to indices, minus 1 over 3 x raised to the power Okay, so this is a cubic root. So cubic root of x squared, right? So if that's the case, then this becomes x raised to the power minus 2 over 3. Okay, so we can now apply the power rule, and that gives us f prime of x to be equal to what? Minus 1 times x raised to the power of minus 1 minus 1, remember, minus 2 over 3, remember, x raised to the power minus 2 over 3 minus 1, right? And that brings us to f prime of x equals minus 1 over x squared plus 2 over 3 x raised to the power minus 5 over 3. Right? Good. So I'll drop one question here, so you can try this on your own. So we have f of x equals s squared minus x plus 2. If you are up for it, you can solve this and put the answer in the comment section. Okay, so that is it for the power rule. Now, let's look at the chain rule. Right? Good. All right. So before we look at the chain rule, let's take a look at derivative of exponential functions. Right? So we have say f of x is equal to e raised to the power x. Then f prime of x will be equal to e raised to the power x. Okay, let's look at another example, then I will explain everything together. So we have b, f of x is equal to e raised to the power 2x. Then f prime of x will be equal to what? 2e raised to the power 2x. So what is happening here? You can see that we are only differentiating the power and then multiplying it by the function. That is the rule. Okay, so if we have, say, f of x to be equal to e raised to the power 3x, then f prime of x will be equal to 3e raised to the power 3x. Because if we differentiate 3x, we get what? We get 3. Okay? So what if we have f of x equals 5 raised to the power x? Simply, we have f prime of x to be equal to 5 raised to the power x ln 5. Okay? So the rule says that if we have some function y is equals a raised to the power x, where x is what? The independent variable, then y prime of x, or y prime will be equal to what? A raised to the power x ln a. Okay? Alright. So here, the next thing I want us to talk about is differentiation of trig functions. So I have put together some derivatives of some trig identities. So let's take note. So if we differentiate sine x, we get cos x. We differentiate cos x, we get negative sine x. We differentiate tan x, and we get sec squared x. We differentiate cosec x, and then we get negative cosec x cos x. And it continues. So take note of this. We will use it as we progress. Okay. So now, let's take a look at chain rule. Okay? Let's take a look at chain rule. So for chain rule, we have for example, we have y to be equal to x cubed minus 1 raised to the power 100. Okay? So what we can do is, if we have such a function, we let u to be equal to x cubed minus 1. Right? If we do that, y now becomes u raised to the power 100, and then dy du, if we differentiate y with respect to u, we get 100 u raised to the power what? 100 minus 1, that is 99. Right? Fine. Now we can find du dx. And du dx gives us, this is u, right? If we differentiate u with respect to x, we get 3x squared. Now what happens if we multiply dy du by du dx? So we have dy du times du dx. So you see we have what? Dy dx. Therefore, dy dx will be equal to, so what is dy du? Dy du is 100 u raised to the power 99 times du dx is what? Is 3x squared. So we put them together, and then we have 300 x squared u 99. But what was u? U was x cubed minus 1. So our final answer becomes y prime equals 300 x squared s cubed minus 1 raised to the power 99. Alright, so that is for chain rule. Okay, let's look at an example which involves an exponential function. So for chain rule, we have y equals 10 raised to the power x. Okay, sorry, 10 raised to the power 3x. Now we can let u be equal to 3x. If u is equal to 3x, then the function y now becomes 10 raised to the power u. Okay, Now we can find the y du. Okay? So what is the y du? According to the exponential functions we did earlier, what is the y du? You are right. The y du will be equal to 10 raised to the power u ln u. Okay? Then we need to find du dx. Du dx is now equal to 3, right? Good. So now dy dx will be equal to du dx times dy du, and that is equal to what? 3 times 10 raised to the power u ln u, right? Yet we know what u is. So we have 3 times 10 raised to the power 3x ln ln 10. All right. Ln 10, ln 10. I made a mistake right there, so it's ln 10, okay? Sorry if I've confused you. All right, so that is it. There's another example here. You can take a look at it. You can have y equals cot times cosec x, right? So if you have this, you can employ the rules of differentiation. So let me write the question here again. So we have y equals cot cosec x, and we have to find y prime, right? Y prime will be equal to what? So now we can let cosec x be equal to u. Then we have y is equal to cot u. Okay? So to find the y du, okay, the y du is equal to what? The derivative of cot u. What is cot u? The derivative of cot u. So cot x is equal to negative cosec squared x. So the derivative of cot u with respect to u is negative cosec squared u, right? According to this. All right. So now we need to find the u dx. So the u dx will be equal to d dx of cosec u, cosec x. Fine. So if you differentiate cosec x, we have what? We have differentiate cosec x, we have minus cosec x cot x, right? So at the end of the day, you need to put the two of them together to say that dy dx is equal to minus cosec squared x times minus cosec x cot x, right? This in turn gives us cos x cot x cos squared cosec x. All right, because u is what? U is cosec x. So we have cosec x here. All right, so that brings us to the end of today's work. Today we'll be speaking about power rule and then the chain rule. Right, so we'll continue in the next video. See you.